Hello everyone, in this video I'm going to discuss example for limit. Kindly refers to the question, find each of the following situation. So here we have A, limit when x approaching 3, we have the function x cubed minus 27 over 3 ln 5 minus the ln 5 to the power of x. So if you substitute the situation, then we will have 0, 27 minus 27, we will have 0 over 0. So in here we have the indeterminate form. So we have multiply by the conjugate, factorize the situation, or long division. So for this case, my suggestion would be long division. So before we start, kindly simplify the situation given. Limit when x approaching 3. For the situation x to the power 3 minus 27 over, we have the situation given 3 ln 5 minus, we have the x ln 5. So ln 5 is the constant. So we write limit when x approaching 3. So we have x to the power 3 minus 27 over, we have the ln 5 bracket 3 minus the x. So notice that it is an improper fraction, so we can make use of the long division. So we have x to the power 3 plus 0x squared plus with the 0x plus with the situation, in here we have negative 27. So x minus x plus with the 3. So negative x squared. So we will have x cubed minus 3x squared. So from here we have 3x squared and then plus with the 0x and then minus 27. So continue, negative 3x. So we have 3x squared minus 9x. So in here we will have 9x minus 27 minus the 9. So we have 9x minus 27. So we will have the remainder as a 0. We write the situation limit when x approaching 3. For the situation given, here we have negative bracket x squared plus with the 3x plus with the 9 multiply with 3 minus the x over, we have the ln 5 bracket 3 minus the x. So notice that we have the common terms in here. So we can simplify. So if we simplify, limit when x approaching 3, we have the negative bracket x squared plus with the 3x plus with the 9 over the ln 5. So the answer would be 3 squared, we have 9 plus with the 9 plus with the 9, we have negative 27 over the ln 5. So that is the value of y when x approaching 3 for the function fx, then we have negative 27 over ln 5. Next, kindly refers to b. Limit when x approaching 7 from the left for the function given. Let's define the function. We have modulus 7 minus x. If we define, we have 7 minus x and we have negative bracket 7 minus x. So with the domain x less than equals to 7, x greater than 7. So that is the definition. So here we have the 7. If greater than 7, we have negative bracket 7 minus x. If less than 7, we have 7 minus x, including the 7 as well. So limit when x approaching 7 from the left. So we have exponent 3 bracket, we have 7 minus x over 49 minus x squared, we have 7 minus x, 7 plus with the x. Notice that we have the common terms. So we can simplify. Kindly rewrite the question. 7 from the left, exponent 3 over 7 plus with the x. So the value of y will be exponent 3 over 40. Hello everyone, in this video I'm going to discuss the example for differentiation. So if exponent xy plus with the y equals to 7x, find the divided x and then evaluate the divided x when y equals to 0. So before we start to differentiate, kindly evaluate the situation when y is equals to 0. So we will have the situation 1 plus with the 0 equals to 7x. So x will be equals to 1 over the 7. So in here we have the situation x is equals to 1 over 7, or we can say it 1 over 7, 0. Next, differentiate the situation, or we can say find the divided x. Differentiate the exponent xy, we have exponent xy bracket, product rule, y, differentiate the x and we'll have 1. Plus, we have x, differentiate the situation, we will have y prime. Plus, we have the y prime, if we differentiate the y, Then continue, we have the 7. So kindly substitute the value when x is equals to 1 over 7 and y is equals to 0 in order to find the y prime. So in here we have 1 bracket, the y would be 0 plus with y prime over the 7. Plus we have the y prime and then equals to 7. So in here we have y prime plus we have the bracket 1 over 7 plus with the 1 equals to 7. So we have 8 over 7. Here we have y prime equals to 7. So the dy dx, or we can say the y prime, equals to 49 over the 8. Kindly refers to b. Given that we have the fx, which is equals to negative 2x plus 9 over x squared, by using the first principle, find the f prime x. So given the situation, limit when h approaching 0, f bracket x plus with the h minus fx. Then here we have the h. Kindly substitute the situation given. So limit when h approaching 0. So we have f bracket x plus h. So in here we have 9 over bracket x plus with the h bracket square minus 2 bracket x plus with the h. Then minus, we have the fx. So if you minus, so we will have 9 over x squared plus with the 2x over the h. So kindly rearrange the situation given. Limit when h approaching 0, we have 9 over bracket, we have x squared plus with the 2xh plus with the h squared. Minus, we have 9 over the x squared. And then minus, we have the 2x, minus, we have the 2h, and then plus with the 2x over the h. Kindly simplify the situation given. So if we simplify the situation given and notice that we have 0 for this part. So continue, we have limit h approaching 0, we have the 9x squared minus, we have the 9 bracket x squared plus with the 2xh plus with the h squared over, we have the x squared bracket x plus with the h bracket square minus the 2h over the h. Kindly simplify the situation. So notice that if we have 9 squared minus the 9 squared, then we will have 0. So limit when h approaching 0, we have negative 18xh minus the 9h squared over, we have the x squared multiply with x plus with the h bracket square. Here we have the h and then minus with the 2 if we simplify the situation. So notice that we have the common term h over here, h over here. We can simplify. Limit h approaching 0, we have h bracket negative 18x minus 9h over the h bracket x square bracket x plus with the h bracket square minus with the 2. So limit h approaching 0, negative 18x minus 9h over, we have the x square bracket x plus with the h bracket square minus with the 2. Kindly substitute the h. So we will have the situation f prime x, which is equals to, we have negative 18x over, so we have x to the power 4 minus with the 2. Finally, the f prime x, which is equals to negative 18 over x to the power 3 minus the 2. So that is the first derivative by using the first principle. Hello everyone, in this video, I'm going to discuss the example for application of differentiation regarding the experiment problem. A curve has the equation, so here we have y, which is equals to 6x to the power 3 minus 9x squared minus 36x plus with the 90. Find the coordinate of the stationary point and determine whether this is a maximum or a minimum by using the first derivative test. So step number 1, we have the equation. Step number 2, find the dy dx. So we have the y prime, which is 18x squared minus 18x minus 36. Third step, find the critical number. So here we have factor out the 18. X squared minus the x minus the 2 equals to 0. So 18 bracket, we have x minus the 2, x plus with the 1. So continue. So the value of x will be equals to 2, the value of x will be equals to negative 1. So here we have the critical number. Next is to find the y. Kindly substitute into the calculator. When y is equals to 30, if x equals to 2, when x equals to -1, we have the y which is equals to 111. So we have the point 2, 30, we have the -1, 111. That is what we call the stationary point. Next is to test the situation. So given we have x which is equals to -1, x which is equals to 2, so the interval will be -infinity until -1, -1 until 2, and then 2 until infinity. Suggested value will be -2, here we have 0, and then here we have the 3. By substitute into the f prime x, or we can say the y prime, so here we will obtain 72, -36, and 72. Notice that we have increasing, decreasing, and increasing. So this part we will consider as maximum point, which is -1, 111. For this part we will consider as minimum point for the situation 2, 30. So that is the situation. Hello everyone, in this video I'm going to discuss the example for complex number. So the complex number z is given by the situation here. Find the modulus and argument of z. So if you notice that here we consider as the polar form. Same goes to this part as a polar form. So what we have to do is to convert the polar form to the Cartesian form. So how to convert into the Cartesian form? Very easy, just to expand the situation. So by referring to the special angle, we have cos pi over 3. When we know that pi over 3 actually equals to 60, so if we have the cos 60, so means that we have the situation, here we have SET2 bracket, here we have 1 over 2 minus. For the sine 60, we know that based on the special angle, which is square root of 3 over the 2i over, so if cos 45, we have the square root of 2 over the 2 plus we have the square root of 2 over 2 as well for the sine 45. So now we have the situation. Try to expand the situation given. So we have square root of 2 over 2 minus the situation. We have square root of 2, square root of 3 over the 2i over. We have the square root of 2 over 2 plus with the square root of 2 over 2i. So try to simplify the situation. So for the situation z, we have square root of 2 minus the square root of 2 square root of 3i over the 2 over. We have the square root of 2 plus the square root of 2i over the 2. If we simplify, automatically we will have square root of 2 minus the square root of 2 square root of 3i over the square root of 2 plus with the square root of 2i. So that will be the simplest form. So next, we can factor out the square root of 2. So in here we have 1 minus the square root of 3i over. So for the bottom part, we also have the square root of 2. So we have 1 plus with the I. So now we can simplify. So when we simplify, we have 1 minus square root of 3i over 1 plus I. So multiply by the conjugate, here we have 1 minus the I over 1 minus the I. So we expand the situation. Then we have z, which is equals to 1 minus the I minus the square root of 3i. And then we have the situation minus the SET3 over. Make use of the formula 1 plus with the 1. So z will be equals to 1 minus square root of 3 plus we have -1 negative square root of 3 bracket I over the 2. Rewrite the situation. We have 1 minus square root of 3 over the 2 minus we have bracket 1 plus with the SET3 over the 2i. So that will be the Cartesian form. Refers to the calculator. Actually z, which is equals to -0.366 minus 1.366i. So next, what we have to do is to focus on the modulus of the z. So since we have the z, so now we are going to find the modulus of z. Modulus of z, where we have square root 1 minus SET3 over 2 bracket square plus we have the situation 1 plus with the SET3 over the 2 square. So the modulus of z will be equals to square root of 2. Next is to find the argument. So first of all, we have the step Argand diagram. So the location of the z is located at the third quadrant. So here will be the basic angle. So here will be the z. Second step, we have the modulus of z, where we have square root of 2. Third step, we are going to find the tangent alpha, which is equals to, do remember, ignore the negative sign. So if we ignore the negative sign, then we will have the situation 683 over 183. So the basic angle would be 75 degrees. So in order to find the argument, step number 4, argument of z, where we have negative 180 plus with the 75, so the answer will be negative 105. So argument of z in the form of radian, 105 multiplied with the pi over 180, so the answer will be negative 7 over 12 pi in the form of radian. So if we want to express in the form of decimal, it will be negative 1.83 radian. So the question asks us to find the modulus of z and also the argument of z. So if you want to express in the form of polar form, so the z will be equals to square root of 2 bracket. So here we have cos bracket negative 7 over 12 pi plus I sine bracket negative 7 over 12 pi. So that would be the polar form. Hello everyone, in this video I'm going to discuss the example for absolute value and also the inequalities. Solve, we have the situation modulus 9x minus 3 to the power of x minus 3, which is equals to 3. So kindly define the situation. We have 9 to the power of x minus 3 to the power of x minus the 3, which is equals to 3, or we have 9x minus 3 to the power of x minus 3, which is equals to negative 3. So kindly rewrite the situation. So we have 3 to the power of x bracket square minus 3 to the power of x and then minus the 6, which is equals to 0. So y is equals to 3 to the power of x. If we substitute, we will have y squared minus the y minus the 6 equals to 0. So if we factorize, we have y minus 3, y plus the 2 equals to 0. So 3 to the power of x equals to 3. 3 to the power of x equals to negative 2. And notice that this one cannot be done because we have ln 3, ln negative 2 does not exist. So for this case, x is equals to 1. Valid. Another part, we have 3 to the power of x bracket square minus 3 to the power of x and then equals to 0. So let y equals to 3 to the power of x. So we have y squared minus y, which is equals to 0. Y multiplied with y minus 1 equals to 0. So for this case, we have 3 to the power of x, which is equals to 0. 3 to the power of x, which is equals to 1. So for this case, again, ln both sides, ln 3 and ln 0, which is does not exist. So for this case, we have 3 to the power of x equals to 3 to the power of 0. So x will be equals to 0. So valid for this case. So kindly refers to B. Find the solution set of the inequalities. First, we split the situation based on the definition. We have 4x minus the 4 over 2x plus the 3 greater equals to 1. And we have 4x minus the 4 over 2x plus the 3 less than equals to 3. Kindly rearrange the situation and then equal the denominator. So we have 4x minus the 4 minus bracket 2x plus the 3 over, we have 2x plus the 3 greater equals to 0. Kindly expand the situation. So we have the 2x minus, we have the situation negative 7 over 2x plus the 3 greater equals to 0. Next, determine the sign where we have the positive. So we have x greater equals to 7 over 2, x greater than negative 3 over the 2. Use the number line. We have negative 3 over 2, 7 over 2. Empty circle, then circle. So here we have the negative, and then here we have the positive, negative, and positive. We are interested in positive. So the answer will be negative infinity until 3 over 2. Negative 3 over 2 is not included. Union 7 over 2 until infinity. So that is the answer or interval for the left hand side. Focus on the right hand side. We have 4x minus the 4 minus the 3 bracket 2x plus the 3 over, we have 2x plus the 3 less than equals to 0. So continue, 4x minus the 6x, so here we have negative 2x. Negative 4, negative 9, we have negative 13 over 2x plus the 3 less than equals to 0. So continue, determine the sign, we have the negative. So from here, we have negative 2x minus 13 greater equals to 0. So x less than equals to negative 13 over the 2. Continue. X is greater than negative 3 over the 2. By using the number line, illustrate the situation. So in here, we have the situation. Negative 13 over the 2, negative 3 over the 2. So then circle. So empty circle. So the sign will be negative, 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 negative. So negative, positive, negative. So we will choose the negative sign. So the answer will be negative infinity until negative 13 over 2. Union. So negative 3 over 2 until infinity. So combine them by using the real number line. So here we have negative 13 over 2. Continue, we have negative 3 over 2. And then finally we have 7 over 2. Based on the red in color, the answer will be empty circle towards the left. Then circle towards the right. Green in color, we have the then circle towards the left. Then we have the empty circle towards the right. So based on the definition N, so our answer would be find the intersection. So here will be the intersection. The second part will be here will be the intersection. So the answer must be in the set solution. So x such that we have x less than equals to negative 13 over the 2, or x is greater and equals to 7 over the 2. So that is the solution set. Hello everyone, in this video I'm going to discuss the example for function and graph. Kali refers to the example given that we have the function f and also its inverse. So based on the situation given, meaning that we have f row, f inverse, so we will have the value x. So using the substitution method, because we are going to find the situation given. So kindly substitute the f inverse into the ln. So based on here, we have ln bracket. So if we substitute the situation, so we will have a f inverse over the 2 f inverse minus the b, which is equals to x. So kindly exponential, or we can say transform the ln from the exponent. So we have a f inverse over 2 f inverse minus the b equals to exponent x. So kindly rearrange the situation. A f inverse equals to exponent x bracket 2 f inverse minus the b. So a f inverse equals to 2 exponent x f inverse minus the exponent x b. Rearrange the situation. So here we have the exponent x b equals to f inverse bracket 2 exponent x minus the a. So the f inverse x, which is equals to exponent x, we have the b over, we have 2 exponent x minus the a. So kindly compare the situation what we have into 3 exponent x over, we have c exponent x minus with the 5. So in here we have a, which is equals to 5, b, which is equals to 3, and then c, which is equals to 2. Next, Kali refers to b. The function given, we have the gx, and the composite function, we have the g rho h. Shows that the hx, which is the modulus of x minus 2 over x. Kali refers to the composite function, we have the g rho h, which is equals to 3x squared plus with 12 over x squared minus the 14. Substitute the situation hx into the g. So here we will have 3h squared minus the 2. So we have 3x squared plus with the 12 over x squared minus the 14. So can we rearrange the situation? So here we have 3h squared, or we can say the h squared, which is equals to 3x squared plus with 12 over x squared minus with the 14 plus with the 2 over the 3. So h squared will be equals to, so we have the x squared, and then plus we have 4 over the x squared, and then again we have the negative 12 divided by 3, so we will have the negative 4. So based on the situation given, we notice that modulus of x actually equals to square root of x squared. So kindly express the situation hx, where we have the square root of, continue, we have the situation x squared plus with 4 over x squared minus the 4. So based on here, we have to equate the denominator. So we have square root, we have x to the power 4, and then minus 4x squared, and then plus with the 4 over the x squared. So we may factorize the situation given. So square root. If we factorize the x squared minus 4x squared plus with the 4, we will have x squared minus with the 2 bracket square over the x squared. So rewrite the situation hx, where we have square root of, we have x squared minus the 2 over the x bracket square. So simplify, we will have the modulus x squared over the x minus 2 over the x. Again, we will have x minus 2 over the x, and we have the modulus, so we have the hx. So we already shown the situation given. Next, state the domain. So refers to the situation, the domain for h will be negative infinity until 0, union 0 until infinity. Reason, because here cannot be equals to 0. Hello everyone, in this video I'm going to discuss an example for function and graph. Given we have the function long, okay, so show that fx is one-to-one function. So let's begin. Fx sub 1 equals to fx sub 2. So negative ln, we have the bracket 4x sub 1 minus the 3 plus with the 5 equals to negative ln bracket 4x sub 2 minus the 3 plus with the 5. So we may simplify the situation, plus with the 5 plus with the 5. So 0, and then we have to rearrange. So we have ln bracket 4x sub 2 minus the 3 equals to ln 4x sub 1 minus the 3. So we may compare. So 4x sub 2 minus the 3 equals to 4x sub 1 minus the 3. We may rearrange and then simplify. So we have 4x sub 1 equals to 4x sub 2. So x sub 1 equals to x sub 2. Shows that fx is 1-to-1 function. Reason, because we have x sub 1 which is equals to x sub 2. So curly refers to b is to find the f inverse. So let's say we have fx which is equals to, we have 5 minus ln bracket 4x minus with the 3. Y is equals to fx. So we have the statement f inverse of y must be equals to x. So y is equals to 5 minus ln bracket 4x minus 3. Rearrange ln bracket 4x minus 3, where we have 5 minus the y. 4x minus the 3 equals to exponent 5 minus the y. So x is equals to exponent 5 minus the y plus with the 3 over the 4. So f inverse of x is equals to exponent. We have 5 minus the x plus with the 3 and then over the 4. So that is the f inverse. So given the situation, we have fx which is equals to 5 minus ln bracket 4x minus the 3. And then for the f inverse, we have the situation which is exponent 5 minus the x plus with the 3 over the 4. So f and also the f inverse. Continue, state the domain and range for the f and also the f inverse. So kindly refers to the f. So based on the situation given, they said that x must be greater than equals to 1. So the domain for the f would be 1 until the infinity. As for the range, we have to refer to the graph later on, or we may refer to the situation given. So as we all know, domain for the f actually is the range for the f inverse as well. Later on only we decide what is the range for the f and also the domain for the f inverse. Curly refers to the D. Sketch the graph of the fx and also the f inverse on the same axis. So refers to the f. At first we have y equals to ln bracket 4x minus the 3. So here we have x greater than 3 over the 4. So the asymptote will be 3 over 4. So if it refers to the graph, we will have something like this. So the graph will be something like this. Y must be like this. Because of the situation, they said x must be greater than equals to 1. So because when we substitute x equals to 1, so notice that here in here we have 4 minus 3, which is ln 1. So x equals to 1, y will become 0. That's why we have the dot at the bottom and only have the solid graph at here. So that will be the graph for the situation. Next, if y is equals to negative ln bracket 4x minus the 3, so the graph will be something like this. So here we have 304. So the graph will be something like this, because we flip the situation due to the negative. Continue. Next, we have to add on the 5. When y equals to 5 minus ln bracket 4x minus the 3. So means that we have to shift up this thing for 5 units. So later on, we'll refer to the graph. So continue. Here we have the situation when x is equals to 3 over the 4. Okay, then continue. So in here we have 1, 0. If we shift upward, we will have 1, 5. So here we have 1. Let's say we have 1, 2, 3, 4, and 5. Here will be the coordinate. Then continue. In order to find the y equals to 0, we have 0 equals to 5 minus the ln bracket 4x minus the 3. So ln, we have the 4x minus the 3 equals to the 5. Then continue, we have e to the power of 5 and then plus with the 3 and then over the 4. So that is the value for x. So based on the situation given, so x is equals to e to the power 5 plus with the 3 over the 4. So you may refer to the calculator, which is the big number, maybe around 30 until 40. So let's say here will be the intersection, where we have e power 5 plus with the 3 over the 4 and then 0. So the graph will be something like this. Okay, so that is the graph for the fx. Continue. Next, what we have to do is to find the inverse. So for the inverse, we have the situation. So here we have 1, 5. So if we flip, at first we have to flip the x, which is equals to y. So here, let's say we have the situation y, which is equals to x. So 1, 5, it becomes 5, 1. So here we have 1, 2, 3, 4, and 5. So here we have the 1. So let's say 5, 1 is located around here. So we have 5, 1. Next, based on the situation given in here, we have 0. So it must be something over here. Next, x equals to 3 over 4. We will change it to y is equals to 3 over 4. So the graph will be something like this. So here, let's say we have the situation 0, e to the power 5 plus with the 3 over the 4. So here we have the y-axis. Here we have the x-axis. Then we must have the y equals to x, and then the intersection point, and also the asymptote for the y and also the x. So basically that is the graph. So do remember, based on the situation, we must find the range as well. So range for the f, you may refer to the red in color. So the highest will be the 5. So domain 1 until infinity, range for the f would be, the highest would be the 5. Okay, the highest will be the 5. So negative infinity until 5. So that is the answer for the situation given. Hello everyone, in this video I'm going to discuss the example for limits and continuity. Kindly refers to the question, evaluate the situation where we have a limit when x approaching 3 from the left. For the function, we have x squared minus 5x plus with the 6 over, we have the modulus 3 minus x. So my advice is to focus on the modulus, where we have to define 3 minus x, where we have the positive 3 minus x, and we have the negative bracket 3 minus x. So for the domain, we have x less than equals to 3 and x greater than 3. So illustrate the situation in the real number line. For the x less than equals to 3, the function will be 3 minus x bracket. For the situation x greater than the 3, where we have negative bracket 3 minus the x. So that will be the function. So focus on the question, limit when x approaching 3 from the left. So here will be our focus, 3 from the left. Where we have the factor, the x squared minus 5x plus with the 6. So when we have x minus the 3 multiplied with x minus the 2 over, we have the 3 minus the x. So continue. If we substitute the situation, and we will have 0 over 0, where we have the indeterminate form. So the suggestion will be factorize, conjugate, long division. So for this case, factorization will be the suitable strategy. So limit when x approaching 3 from the left, kindly factor out the negative. So here we have 3 minus the x, and then x minus the 2 over 3 minus the x. Notice that we have the common terms over here. So we can simplify. Rewrite the situation limit when x approaching 3 from the left, we have the negative bracket x minus the 2. Kindly substitute the 3, then we will have the situation which is equals to negative 1. Or we can say approaching the negative 1. When x approaching 3 from the left for the function fx. Kindly refers to b. A function fx is defined as follows. Again, notice that we have the modulus of x minus 2. Kindly define the situation. So in here, the modulus for x minus 2. So here we have x minus 2, negative bracket x minus 2. So based on the situation, we have x greater or equals to 2, x less than the 2. Again, define the situation in a real number line. So here we have the 2. If x is equals to 2, the value of y will be 0. If x is not equals to 2, either the left hand side or the right hand side. So for the left hand side, meaning that we have the refers to the number line. Here we have the 2. Here we have x minus the 2 when x greater than 2. Less than 2, we have negative x minus the 2. So kindly substitute the situation. So from the left, we have negative bracket x minus the 2 over x minus the 2. For the right hand side, we have x minus the 2 over x minus the 2. So determine the continuity for the function fx at the x is equals to 2. Step number 1, f2. By referring to the number line, so here we have 0. Second step, find the limit when x approaching 2 from the left, limit when x approaching 2 from the right. So the situation will be negative bracket x minus the 2 over x minus the 2. The value of y will be negative 1. As for the right hand side, we have x minus the 2 over x minus the 2, and the value of y will be approaching 1. So limit when x approaching 2 from the left for the function fx, is it equals to the limit when x approaching 2 from the right for the function fx? Notice that from the left we have negative 1, from the right we have the 1. So the situation is not equal. Again, limit when x approaching 2 for the function fx does not exist. So step number 3, we can say that when the step number 2 does not qualify, automatically we can say fx is not continuous at x is equals to 2. Hello everyone, in this video I'm going to discuss the example for limits and also the asymptote. Given the question, we have y which is equals to 2x over the square root of x squared minus the 9. So by finding the limits appropriate point, obtain the vertical and also the horizontal asymptote. Then if possible, we can make use of the situation given to sketch a graph. So first, what we have to do is to find the domain. So let's focus on the domain. In here, we have 2x over the square root of x minus the 3, x plus with the 3. So for this case, it is all real number because it's a linear case. For the bottom part, we notice that we have the surd. So in here, the surd must be greater, actually is equals to 0. But for this case, since the surd is in the denominator, so we have to ignore the equal sign. So we can say x minus the 3, x plus with the 3 greater than 0. So determine the sign. We have the positive. Then we say x is greater than 3, x is greater than negative 3. By referring to the number line, we have negative 3 and also the 3, empty circle, then here we have the negative, negative, negative. So positive, negative, positive. So we prefer the positive based on the situation given. So the domain would be negative infinity until negative 3, union, start from 3 until infinity. So that would be the domain for the graph fx. Continue for the second step is to determine the xy intercept. So here we have x-intercept when y is equals to 0. So when y equals to 0, automatic x is equals to 0. In order to find the y-intercept, x must be equals to 0, and then we will have does not exist. So actually both also does not exist. Reason refers to the real number line. So here we have negative 3 and here we have 3. So based on the domain given, actually here we have the graph. Same goes to this part, but not for this part. Kindly refers to the x-intercept. When x equals to 0, y also equals to 0. So based on the situation given, here does not have any graph. So we can say it does not exist as well. So back to the story. So let's say refers to the real number line. Here we have the suggested value negative 3.001. So here we will have the situation negative 2.999. For this part we will have 2.999 and here we have 3.0001. Step number 3, move on with the vertical asymptote. So here we have x is equals to negative 3, x is equals to 3. Limit when x approaching negative 3 from the left, limit when x approaching negative 3 from the right. Again, limit when x approaching 3 from the left, limit when x approaching 3 from the right. Kindly substitute the function given. So here we have So now move on with the calculator. So kindly key in the function given. Next, substitute this value and we will have the situation negative 3.001 as the limit when x approaching negative 3 from the left, the value will be negative infinity. Continue. Negative 3 from the right, if we substitute this value and we will have does not exist. Next, for 3 from the left, substitute this value, again we will have does not exist. And then finally limit when x approaching 3 from the right, if we substitute this value and we will have the situation positive infinity. So the meaning positive infinity means that the graph increasing as they approach the 3 from the right. Same goes to the negative 3 from the left, they were decreasing. So vertical asymptote are x equals to negative 3, x is equals to 3. Next, we are going to move on with step number 4, the horizontal asymptote. Limit when x approaching negative infinity. For the situation given, focus on this part. We have to factor out the square root of x squared. So here we have x bracket the 2 over, we have to factor out the square root of x squared. So here we have the square root 1 minus 9 over the x squared. So refers to the negative infinity, means that here we will have the negative x. So rewrite the situation. So here we have x bracket 2 over, here we will have negative x square root, we have 1 minus 9 over the x squared. So kindly refers to the situation. If we substitute negative infinity, here we will have 0. So refers to the situation, then here we will have negative 2 over the 1. So here we will have the horizontal asymptote, y is equals to negative 2. Next, move on with limit when x approaching positive infinity. So repeat the situation. Here we will have x instead of negative x. So square root 1 minus 9 over the x squared. So if we substitute, here we'll obtain 0. Then for this part, we will have the 2. So horizontal asymptote, y is equals to negative 2, y is equals to 2. So for extra situation, let's say we want to sketch the graph. So here we have the y, here we have the x. Kindly refers to the domain. Here we have the negative 3, negative 1, negative 2, and negative 3. So 1, 2, and 3. Continue. Refers to the second step. We have no intersection between the x-axis and also the y-axis. Number 3, vertical asymptote. Negative 3 from the left, the graph will be decreasing. Negative 3 from the right does not exist, so nothing happened. 3 from the left, nothing happened. 3 from the right, so we have increasing because of positive infinity. Next, move on with the horizontal asymptote. Negative 2, let's say here we have negative 1, negative 2. So y is equals to negative 2. As x approaching negative infinity, we will have two possible, either above negative 2 or below the negative 2. Again, 1 and 2. So here we have y which is equals to 2. Again, we have 2 possible, above the 2 or lower the 2. By referring to the calculator, you have to key in this function and then substitute the value when x is equals to negative 50. And we notice that we have the value lower than the negative 2. So the graph will be something like this. Again, repeat the situation by substituting the x which is equals to 50. And we notice that we have the value y which is greater than the 2. So the graph will be something like this. So that is the graph for the fx, or we can say 2x over the square root of x squared minus the 9. So do remember, the graph sketching is just for extra information, how we make use of the information given, or also the information we have to sketch the graph. Hello everyone, in this video I'm going to discuss the example for differentiation. Kindly refers to the question, find the dy dx for the situation given where we have y which is equals to sine 2x multiplied with the cos x minus we have cos 2x multiplied with the sine x and then plus sine 2x multiplied with the sine 5x plus cos 2x multiplied with the cos 5x. My suggestion is to refer to the factor formula. So here we have the suggestion, sine bracket a minus b. So we will have sine a cos b minus we have the cos a sine b. So refers to this part, then we have this part. That is number 1. Number 2, cos bracket a minus the b. So we will have cos a cos b plus we have the sine a sine b. So again refers to this part and also this part. Focus on the blue in color. So here we will have y which is equals to, from the summation we have to do it as a product. So a will be 2, b will be 1. So in here we have sine bracket 2x minus the x. That is for the front part. And then for the back one, refers to the green in color. So notice that this one will be the a, this one will be the b. So we have cos bracket a will be 2x minus the b will be 5x. So simplify the situation. So y is equals to sine x plus we have cos negative 3. So for the cos, the negative will be positive because of the quadrant. So for this part, cos negative actually equals to cos positive. So here we will have cos 3x. Next, differentiate the situation. We have dy dx. So here we will have sine x, it become cos x minus we have 3 sine 3x. So that is the dy dx. Kindly refers to b. Given we have y over x equals to exponent x squared. Question asks us to show the situation given. So my suggestion is to rewrite the situation given where we have y which is equals to x multiplied with the exponent x squared. So let's begin with the product rule. We have y prime which is equals to v u prime plus u v prime. So let's begin. Y prime equals to exponent x squared multiplied with the 1 plus we have x, differentiate the exponent. So here we have the situation and then differentiate the power, then we will have 2x. So rewrite the situation, y prime equals to exponent x squared plus we have 2x squared multiplied the exponent x squared. So that is the first derivative. Next, if it refers to the question, notice that we have y which is equals to x exponent x squared. So meaning that we can refer to this part and also this part. So we can simplify the situation. So y prime is equals to exponent x squared plus we have the 2x, then we have the y. So next, move on with the second derivative. So in here we have the second derivative. So again we have exponent x squared and then we have the 2x after we differentiate the power plus we have the 2, again product rule, y and then 1 plus we have x and then we have the y prime. So y double prime equals to 2x exponent x squared. So notice that we have the x exponent x squared where we will have the y. and then plus we have the 2y plus we have the 2xy prime. So kindly refers to the questions. First, we already have the second derivative. Next, we have to rearrange negative 2xy prime, then minus 4y, which is equals to 0. So for the second derivative, minus the 2x multiplied with the dy dx, and then minus with the 4y equals to 0. So we already shown the situation given. Hello everyone, in this video I'm going to discuss the example for parametric differentiation. So kindly refers to the question, given the parametric equation where we have the situation x is equals to exponent to t. Then we have the y, we need to do some modification. So 1 plus with the exponent to t to the power negative 1. Continue. Differentiate the x with respect to t. Then we will have 2 exponent to t. Differentiate the y with respect to t. So here we will have negative bracket 1 plus exponent to t bracket power negative 2. Differentiate the internal function. So we will have the situation exponent to t. Differentiate the power, then we will have 2. Kindly rewrite the situation dy dt equals to negative 2 exponent to t over 1 plus the exponent to t bracket square. Next, find the dy dx. So dy dx is equals to dy dt multiply dt dx. So we have negative 2 exponent to t bracket 1 plus the exponent to t bracket square multiply. Do remember, flip the situation 1 over 2 exponent to t. So finally, the dy dx will be equals to negative 1 over 1 plus the exponent to t bracket square. So kindly refers to the question. Question asks us to show the dy dx less than 0. First of all, refer to bracket 1 plus the exponent to t square. As we all know, based on these parts, we have to note that it is always positive because of the square. Continue. Refer to this part as a whole. So since this is a positive, then multiply with the negative, then it is always negative. So from here we can say that dy dx is less than 0, and then we already shown the situation given. Kindly refers to the second one. We are going to find the second derivative. As we all know, the formula for the second derivative will be d dt bracket dy dx, and then multiply with the dt dx. So let's begin. Differentiate this part. So here we will have 2 bracket 1 plus the exponent to t bracket negative 3. Differentiate the internal function. So when we differentiate the internal function, we will have 2 exponent to t. Then multiply with this part. So again, we will have 2 exponent to t. So finally, we have 2 over 1 plus the exponent to t bracket to the power of 3. That is our second derivative. Next, when t is equals to 0. So kindly substitute. E0 we have 1. 1 plus with the 1 we have 2. 2 to the power of 3 we have 8. So in here 2 over 8 when we have 1 over 4. So that is the value for the second derivative when t is equals to 0. Hello everyone, in this video I'm going to discuss the example for application of differentiation. Given we have the hx, which is x to the power 3 minus 3x squared minus 9x minus with the 5. Express hx in the form of we have x plus with the a bracket square multiply with x plus with the b. B, use the second derivative test to determine the nature of the stationary point, and then C, sketch the graph. So for the case A, my suggestion would be use the try and error method in order to find one of the factor. So for example, so hx, which is equals to x to the power of 3 and then minus 3x squared minus with the 9x minus the 5. Kindly key in the function into the calculator and then make use of the calculator with the function calculate. So for example, h0 we have negative 5, and then we have h2 which is equals to negative 27, h bracket 5, then we have the 0. So means that x minus the 5 is a factor. Continue, make use of the long division. So in here we have x to the power 3 minus 3x squared minus 9x minus with the 5. So here we have x minus with the 5. So x squared in here we have x to the power 3 minus 5x squared. Continue, we have x cubed minus the x cubed, 0. Then here we have 2x squared minus with the 9x minus with the 5. Continue, multiply with the 2x. So here we have 2x squared minus with the 10x. So here we have x minus with the 5 and then plus with the 1. So x minus with the 5. And we have the remainder 0. Rewrite the situation. So hx is equals to, so x squared plus with the 2x plus with the 1 multiplied with x minus the 5. Factorize this part. Hx, we have x plus with the 1 bracket square multiplied with the x minus with the 5. So from here, kindly compare the situation. Then we will have the situation A, which is equals to 1, and then the B, where we have negative 5. Kindly refers to B. Use the second derivative test to determine the nature of the stationary point. So let's say here we have the step number 1. Step number 2, find the h prime x. So here we have 3x squared minus 6x minus with the 9. For the second derivative, we will have 6x minus with the 6. Next, step number 3 is to find the stationary point where we have h prime x, which is equals to 0. So factor out the 3, so we have x squared minus the 2x minus the 3 equals to 0. Factorize, so we will have x minus the 3, x plus with the 1 equals to 0. X is equals to 3, x is equals to negative 1. Kindly substitute the function where we have the hx into the calculator and then make use of the calculate function, determine the value of y when x is equals to 3. So here we have negative 32 and then y when x equals to negative 1, we will have y which is equals to 0. So the point will be 3, negative 32 and then negative 1, 0, which is the stationary point. So that is the situation. Next is to test by using the second derivative, or we have f double prime 0. So if we substitute the x with the 3, 12, which is greater than 0, so it is the minimum point. So the minimum point would be 3, negative 32. F double prime, if we substitute negative 1, then we will have the situation negative 12 less than 0. So a maximum point where we have negative 1, 0. Next, we are going to sketch the graph. So first of all, we must refer to the left hand side. Then we have to add on some info. For example, x-intercept when y is equals to 0. So refers to this part. When y is equals to 0, x is equals to 5, x is equals to negative 1. So we will have 5, 0, and then we have negative 1 and 0. For example, for the y-intercept when x is equals to 0. So if we substitute x equals to 0, we will have the situation y is equals to negative 5. So the point will be 0, negative 5. So that is the xy intercept. Next, we have to refer to the table. For example, we have negative 1 and also the 3. Based on the interval, negative 1, then negative 1 until 3, and then 3 until infinity. Suggested value, let's say here we have negative 2, and then here we have 0, and then here we have 4. F prime x, f double prime x. So if we substitute negative 2 into the first derivative, and we will have 15. If we substitute 0, then we will have a negative 9, and then followed by the 15. Next, if we substitute into the second derivative, for example, negative 2, then we will have negative 18, followed by the negative 6, and then continue, we have the 18. So what does it mean by the first derivative when it's 15? So increasing, this one is decreasing, this one is increasing. Whereas for the second derivative, actually is a concavity. So if it refers to here, we have the negative. Negative means that we have the maximum. So the concave downward, again a negative, we have the concave downward. Then we have the positive, we have concave upward. So kindly refers to the graph. So here we have the y, here we have the x. So basically, based on the situation given, we have the -1. Let's say here we have the -1. Then here we have 1, and then 2, and then the 3. Continue. Based on the situation given, we have to refers to the first derivative. So before, for the first derivative, for the -1 left hand side, the graph is increasing. So try to imagine when we have the graph cubic, something like this. Okay, so in here we have the situation -1. So before that, which is the increasing, and then do remember concave downward. So the graph will be something like this. And then after that, after the -1 until the 3, so where we have decreasing and then again concave downward as well. So the graph will be something like this. And then start from the situation given. From -1 until the 3, we have the concave downward. So the graph will be something like this. And then after that, from the -3 until infinity, we have the concave upward. So the graph will be something like this. So based on the situation given, here we have the -1, 0. Okay, so here. Next, we have the situation in here, we have 0, -5, which is this part. And then after that, we have 5, 0, so which is here, we have 5, 0. Okay, continue. Based on the maximum minimum, again, refers to this part, we have the maximum point. So here we have the maximum point. And then for this point, we have 3, and then -32. So here will be the situation 3, and then -32. So that is the graph for the hx. So do remember, we have the label, the xy axis, and then the points of intersection, and also the maximum and minimum point. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share, and subscribe.